You just clicked on this video, and it loaded for you in less than a second. But it's a gigabyte big, and I'm sure most of you don't have gigabit internet. So how? How does YouTube store the multiple billions of videos and trillions of gigabytes on its servers all on demand and put these videos for you onto a customized homepage and then load them for you in a split second on your demand? Here's the answer for you. Slaves. YouTube has a bunch of child slaves running around trying their best to make the whole system work, except those child slaves are computer programs, and its formal name is this black box called compression. So there's your answer. But you're not satisfied, are you? You want to actually open this big black box and see all the children, programs, running around doing their thing, right? Well, we can do that. So let's use this Mr. Beast video. I spent 50 hours buried alive. A high-energy, VFX-dense video that needs to be displayed up to 4K to uncover YouTube's dirty little secrets. And the trick to understanding it isn't from our perspective, it's from Jimmy's, and it begins the moment we upload the video. When a video is uploaded into the YouTube Creator dock, the system begins ingestion, a process where it verifies the file's integrity and extracts important metadata and analyzes the color profile and bitrate of the video so that nothing is lost. This is when it determines what resolution the video needs to be available in, and the corresponding frame rates. Everything you see when you click that Change Quality button on the bottom right of the video. This all depends on what codec the video is using, MKV, MP4, etc., as this impacts how easily the video can be processed. Once ingestion and metadata extraction are complete, YouTube takes full control of the video through a process called re-encoding and transcoding. Even though Premiere Pro has already compressed the video, YouTube re-encodes it using more efficient, streaming-optimized codecs like VP9, H.264 AVC, and AV1 that are designed for more large-scale streaming. YouTube needs to ensure that a Mr. Beast video plays smoothly, whether you're watching on a high-end PC, a budget smartphone, or even on weak mobile data. This re-encoding method applies two primary types of compression: spatial compression and temporal compression. Spatial compression analyzes each frame, dividing it into smaller sections called macro blocks or transform blocks, then reduces redundant pixel data by prioritizing important visual details like edges, textures, and high contrast areas, while minimizing unnoticeable information. You got all that? Yeah, it's a little dense. Okay, let's use this black square to demonstrate. Is there anything happening here? No. In fact, YouTube knows that there's nothing happening here throughout the entire video, which is what it found when it ingested it. If this video of a black square is just a black square with no changes, YouTube doesn't need to waste its time reanalyzing every frame. It just tells itself, hey, this is a video of a black square. Render the first frame and forget the rest. This reduces the amount of data YouTube needs to use, since it's effectively not doing anything, and is also the reason why when a huge amount of confetti or something like that starts streaming down the video's quality tanks. Because YouTube has no choice but to figure out what each pixel of each frame is. I actually jumped the gun here, because that also bleeds into temporal compression, where YouTube focuses on the differences between frames. Instead of storing each frame separately, YouTube tracks motion and changes, encoding only what actually moves. Techniques like motion estimation and motion compensation allow YouTube to predict and reconstruct frames more efficiently. For example, if Mr. Beast is standing still while text appears on screen, only the new text data gets encoded instead of reprocessing the entire scene. YouTube then transcodes the audio through audio codecs like AAC or Opus to maintain high-quality sound while reducing file size. It kinda works like video encoding, and it kinda doesn't. And I don't have the time to get into it here. If you want a video on that, leave a comment below. After YouTube re-encodes the video, it creates multiple versions at different resolutions and bit rates. This step is essential for adaptive bitrate streaming, or ABR, which ensures smooth playback on various devices and internet connections. Instead of delivering a single high-resolution file that may buffer on slower networks, YouTube provides multiple default renditions, such as 144p, 240p, 360p, 480p, 720p, etc., plus any the creator specifically wants, like 1080p, 1440p, and 2160p or 4K. Each version has its own bitrate optimization, which causes some issues. A 1080p video encoded at 6 megabytes per second may have a lower resolution for 80p version encoded at 1 megabyte per second for users on weaker connections. To counter this, the YouTube player dynamically switches between these versions in real time based on factors like available bandwidth, device processing power, and screen size. But encoding isn't perfect, and it'll sometimes generate artifacts that need to be corrected. All this happens after the initial pass, which includes deblocking filters, noise reduction, and color correction to minimize compression artifacts that may have been introduced during encoding. And you know what else is imperfect? Your coding skills. Sorry, too real? Well, that's fine, because we can use Duolingo to improve it. Oops, I meant Cody. Cody is like Duolingo for code, but better. From C to Python to SQL to Go, Cody lets you learn and upkeep your knowledge on all the fundamental coding languages out there. And they're the sponsors of today's video. For the beginners, it's got everything to make learning and upkeep your coding skills easier. A gamified progression system, personalized learning, an AI tutor, and for the veterans, interview tips, challenges, and advanced topics to keep you sharp. And if you're bored, you can always go to the daily challenge Cody has ready for you. And the best part is that all of this is completely free. Literally $0 to learn a new coding or keep yourself up to date without the stress of figuring out how or what's the best way to do it. Then comes one of the most important steps in the form of keyframe optimization. In short, keyframes are full frames stored at specific intervals in a video to act as reference for the temporal and spatial compression, and whatever else it's doing. Obviously, we can't just have one keyframe from the entire video, but we can't have every frame be the keyframe. So YouTube adjusts these intervals dynamically to improve seeking accuracy. All this means when you skip forward or backward in a video, the playback resumes almost instantly without buffering. Then YouTube multiplexes or muxes the audio and video streams back into industry-standard container formats like MP4 or WebM. These formats provide broad compatibility across devices, whether someone is watching on a smartphone, tablet, desktop, or smart TV, and that's how you get a YouTube video into the servers. We still gotta get this video out to the viewers, and that's where the Content Delivery Network comes in, CDN. Think about it, even after compression, a high-quality video is still a big file. If YouTube had to load every video from a single Centra data center, you'd have to wait forever for it to buffer, especially if you're far from that server. Content Delivery Networks, or CDNs, help YouTube stream videos instantly by storing copies of popular content on multiple servers worldwide. Instead of fetching videos from a distant data center, YouTube delivers them from the nearest CDN, reducing buffering and improving load times. That's why when you hit play on a viral video, it loads instantly. It's probably already stored on a server near you. This means that compression shrinks the video size, making storage and transfer easier, while CDNs handle delivery, ensuring the video reaches you fast and smoothly. That's why, even when millions of people watch the same viral video, it still plays without lag. It's already cached on a nearby CDN server, waiting for you. And it's never just one copy. YouTube has multiple copies of each video. You might laugh at 144p, but that's a dedicated version of the video for people who have extremely bad internet connection. Go up the resolutions, and the higher the bandwidth the resolution is meant for until you hit 4K, 8K, 16K, etc. So next time you wonder why YouTube loads faster on your phone than on your laptop, just remember that the version is probably more compressed and smaller than if streamed on your computer, especially in 4K. Depending on your device and internet speed, YouTube automatically serves the best version for you.